All right, so looking over your homework that I just passed back to you guys, there's a couple things where you've got to be careful to make sure that you follow details. All right, so pay attention, write good notes so that you're doing the procedures the proper way. Does anybody have any makeup work or anything to turn in to me? Go ahead and bring that up to my desk now, please. Just put it right in the corner. Thank you, Brendan. Ashley, question? Show it to me when we're done. Okay. All right, 3.2b, shortcuts when solving equations by multiplication. So the other day when a student asked, what about this procedure, I showed you the reason why I teach you that things multiply times the variable, you move by multiplying both sides by the reciprocal. That should be in your brain. And I also told you that you will answer questions about that as short answer questions. Why? Because that's the thought that should be in your head. That's the thought that should be in your head. So now I want to show you a shortcut, and the shortcut's very, very handy. But like all shortcuts, there's conditions when you can use the shortcut and when you can't. So just be careful. When you can use it, I'm fine with you using it. Not a problem. It works real handily. Right? But it is a shortcut. It won't solve everything using the shortcut. Whereas multiplying by the reciprocal will solve every equation. But it is very, very handy, so I do want you to be aware of it. All right, so number one, when the quantity multiplied times the variable is an integer. Is an integer. All right, let me refresh your memory. Integers are 0, 1, 2, 3, 4, 5, and up. -1, -2, -3, -4, and down, right? Those are integers. So if the coefficient that you're trying to move is an integer, it's real handy to simply divide both sides of the equation by that coefficient. So very, very handy to simply divide both sides of the equation by that coefficient. So let me show you what I mean. So here in our first example, hopefully you agree we need to move the 3, right? The variable, the n, is on the left-hand side of the equal sign. And so we want to move anything on the same side as the n, anything on the left, we want to move to the right. What's on the same side as the n? A 3. And the next thought you have to ask is a 3, okay, when you guys blow your nose, just take it and go back to your desk. We don't sit up at the front and blow our nose. So if the thing is multiplied times variable, as you know, we're going to move by multiplying by the reciprocal. If it's added, we're going to move by adding the opposite. Well, this is an integer, and it's multiplied. We can do the shortcut. We can divide both sides by that 3. So just take your green, do a division bar on the left and put a 3. Do a division bar on the right and put a 3. You can see clearly on the left-hand side, by the way, 3 divided by 3 is 1, not 0. And we end up with 1n, and rightly so, that's what we want. And we all know 12 divided by 3 is 4, and the answer is n equals 4. So again, to finish on the right-hand side, how? Divide both sides by 3. That's all we need to do. Now, don't write this next thing in your notes. I just want to go back and show you the other method. Don't write this. I just want you to watch. So, in this scenario, we would have decided we're going to move the 3, and we'll multiply both sides by the reciprocal, 1/3, right? Now, there's at least one of you out there. Notice this is still right here, right? Notice the variable is still there. There's at least one of you, in doing your work, your variable disappears and then reappears. All right, maybe you're practicing for magic. I don't know. Maybe you're going to be a gospel magician. I don't know. But math can't be magic unless it's Donald Duck in Mathmagical Land. Other than that, you can't have magic. Okay? The variable can't disappear and then reappear, because what's going to happen is you won't know when to make it reappear and where it is. And we're just doing simple stuff now. We're going to get complicated stuff. What I did was I multiplied both sides. You're very annoying with your hand still up. Do you realize that as I don't call on you? So as you multiply both sides by 1/3, right, I have the original. The second line is the first line with 1/3 multiplied times both sides. But notice in reality, what we did is the same thing. Oops, that could be black. That's exactly the same thing as if we divided the left by 3 and the right by 3. And that's why this shortcut works, and it works real handy when it's an integer. It just makes life a whole lot easier and a whole lot quicker if we'll divide both sides by that integer. All right, Kristen, now it's time to ask a question. Always before class starts, so. All right, B. So again, you look at B and you say, hey, what do I want to move? Look, where's my variable? Is it on the right? Is it on the left? Hopefully you all agree it's on the right. Therefore, I want to move the, nope, I want to move the -7. And if you don't make it a -7, you're going to get the problem wrong. Therefore, I have to divide both sides by -7. Now, in this one, I'm going to start on the right. Why did I start on the right on this one, and I started on the left on the other one, Ashley? Because that's where the variable is, and that's the whole reason I'm doing this, right? To move the -7 to the other side. And now I'll go to the other side and do the exact same thing. -7 on the other side. Well, we all know -7 divided by -7 is 1. That leaves me 1x. That's what I want. Positive divided by a negative is a negative, and 28 divided by 7 is 4, so -4 equals x. And the shortcut's really nice. It works very, very nice. It's very, very handy. Luke? You can put x equals -4, but in doing your work, your next step is, what's the left? A -4, and what's the right? An x. However, that is the same. If you're a guy that always likes your variable on the left, you can finish out by switching sides. There's actually a property. I don't know if I've mentioned it to you guys yet, the property that allows you to switch sides. Does anybody remember the name of it? Luke? That's not commutative, because though you may think order, but order is always on the same side. We're swapping sides here. It's different. Brendan? It is not. All right, this property is called the symmetric property, which says you can take anything on the one side of the equal sign, put it on the other, as long as you take everything on the other side and put it on the other. You can swap sides. Symmetric property. So -4 equals x can be made x equal -4 by the symmetric property. And rightly so, it will end up the same. Okay, note this exception. See, again, I'm not a big shortcut teacher. I usually wait a little bit longer and teach you the shortcut, but students always want to do them so fast. So I've given in and taught you the shortcut early. But if you try to do the shortcut now, most students will make a mistake in finishing the problem. Don't do this in your notes. This is, well, go ahead and do that. That's what you'd want to do, right? Isn't that dividing both sides by 7? And on the left, the 7 divided by the 7 will get the n all by itself. Here's my question. How many students know what in the world that is? How many of you think you know what that becomes? Let me see your hand. Nobody? 1. It is doable, actually, but most students don't know. They look at it and say, I don't know what to do now. I'm stuck. Okay, 2 people think they know what to do? Okay. And I believe it. That's plausible. Most students, though, don't know what to do now or get it wrong now. So see the problem with the shortcut? And students then that only learn the shortcut get to here and don't know what to do. Let's do it the way I've taught you without the shortcut. What's on the right-hand side? Let's move the 7/1 by multiplying the left side by 1/7. And let's multiply the right side by 1 over 7. Now on the left, again, the 7's divide out, and we're left with n. But can you finish the right-hand side now? Somebody raise your hand and tell me what the right-hand side becomes. Colby? 5 over 42, right? Because a 6 times 7, 42. Well, you got the right idea, right? Got the right idea. Top times top, bottom times bottom. And we end up with 5 over 42. See, you guys all were able to do that. Because we multiplied both sides by the reciprocal. So again, if you'll keep that in your brain, hey, use the shortcut anytime you can. It's fine. Just make sure you don't forget the basic method that will take care of every issue for you and every problem. Okay? So, yeah, use the shortcut, divide both sides, and it'll make life easier. Okay, let me show you a few other things here. And let me see, I think I want to keep my shade going here a little bit longer. Always gets hard to do when we get down at the bottom. Okay. So let's take a look at this situation. All right, remember, to isolate the variable, it must end up positive. So look at A. All right, technically, right? Technically, what we want to do here is we want to divide both sides by what? Christina? No. Chloe? Okay, and we're going to do the shortcut, so we're just going to divide both sides by -1, right? Again, we don't show the 1, but a negative n is a negative 1n. Hey, that's an integer, right? So we can do the shortcut. I can divide the left by -1. I can divide, the right by -1. I now have the n on the left all by itself, and a positive divided by a negative is a negative, so n equals -7, right? Not a problem. You can see B is the similar type problem, right? The only difference is the variable's on the right instead of the left, and the other side is already negative. Well, again, you want to divide both sides by -1, right? On the right-hand side, -1 divided by -1 is 1. You're left with 1x. On the right, a negative divided by a negative is a positive. You're left with 11. So there's a shortcut. And this will always work, by the way. You can always divide both sides by a -1 when your variable is negative. But there is a shortcut. And I don't know if you've seen it already, but it's real simplistic. If you change the sign of the variable, then simply change the sign of what's on the other side. If you change the sign of the variable, then change the sign of what's on the other side. Now, again, this is a shortcut, right? All shortcuts have limitations. Here's the limitation to this shortcut. The limitation is, all right, let me pause, find her thing so I can keep going here as we're all distracted. Thank you. Amber, can you put that under your desk, please? Thank you. So, all shortcuts have their limitation. Here's the limitation of this shortcut. There can only be one thing on the side with the variable, just the variable, and there can only be one other thing on the other side. Now, you can do it if there's more than one, but you won't know how to do it correctly. So again, you must be down to the negative variable on one side and the number on the other side. And here's the simple thought. Okay, look at A. Our variable is negative. I want to change its sign to positive. Therefore, I must change the sign of whatever's on the other side. So the 7 was positive, therefore now the 7 is going to be negative. And I just took care of that. Now again, you can divide both sides by -1, but that's where you're going to end up. In scenario number 2, which is B, My variable's negative again. I want to change it to positive. So on 3, tell me what the right-hand side will be. Don't say anything yet. Take a look at it. On 3, give me what you think the right side should be. 1, 2, 3. Right? That was negative, so now it's got to go to positive, right? Change its sign. If you're going to change the left, change the right. All right, so C, our variable is on the right, but that doesn't really matter. I don't want it to be negative. Remember, to isolate the variable is to get it to be all by itself and be positive. So now it's positive. And therefore, the left-hand side will be, instead of a negative 2/7, it'll be a positive 2/7. Pretty simple stuff. Pretty simple stuff. So I want you to look up at the board for a moment. Let me take a moment and recap for you. Please don't just pause. Okay, not time to go reaching stuff. I want you to look. I just want to do a quick review. So remember, quantities multiplied times a variable are moved by multiplying both sides by the reciprocal. You'll need to know that for tomorrow's quiz. However, there is a shortcut when the coefficient is an integer. Right? There's a shortcut when the coefficient is an integer, and that shortcut is to divide both sides by that integer. It makes for a quick problem, and so you can see that here. We had a coefficient of a 3. We divided both sides by 3. We're done. On this one, we had a coefficient of -7. We divided both sides by -7. We're done. Don't forget, though, there are limitations. Most of you didn't know how to finish that off. So trying to use the shortcut in that situation left you with not knowing what to do. So again, don't forget, you can always multiply both sides by the reciprocal, right? Don't forget that part. That's what I see students do. And then there's a shortcut to where if your variable is negative, hey, if you're going to change the variable from negative to positive, change the sign of whatever's on the other side. If it was positive, make it negative. If it was negative, make it positive. Okay, any questions about today's lesson, anybody? Okay, got about 14 minutes, so